In the previous video, we covered the third lab in the SQL injection module. So we got some hands-on experience by exploiting a union-based SQL injection in order to determine the number of columns that are being returned by the vulnerable query. In today's video, we'll be using a union-based SQL injection in order to determine the data type of the columns that are returned by the vulnerable query, which is step number 2 in the union-based SQL injection attack. If you don't have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select the learning path, go down, select SQL Injection because that's the module we're working with, go down again, select SQL Injection Union Attacks. So that's the lab we did in the previous lab, which is step number 1 of union-based SQL injection attacks. And today we're going to be doing step number 2. So SQL injection union attack, finding a column containing text. I'm going to right click and open that in a new tab. Okay, before we solve the exercise, we need to cover a little bit of theory on how the union operator works. I've got the notes document open from the previous lab because we covered the first portion of it there, and today we'll be covering the second portion. So in the previous lab, we talked about having two tables, table 1 and table 2. Table 1 had 2 columns, A and B, and table 2 had 2 columns, C and D, and this was the content of table 1, and this was the content of table 2. Now, when I want to combine the results of 2 select queries together, I can use the union operator. So over here, I'm combining the results of this query with this query over here. So select A and B from table 1. So select all the entries in columns A and B from table 1 would output 1, 2, 3, 4. And then select C and D from table 2. So select all the entries from columns C and D from table 2 would output the entries in table 2. So 2, 3, and 4, 5. And using the union operator over here combines the results together. So you see over here, you've got 1, 2, 3, 4. That's the result of the first query. And 2, 3, 4, 5. That's the result of the second query. And that's the way that the union operator works. Now, you can't just simply combine the results of any 2 queries together. Instead, you have to comply by the rules of the union operator, and there are 2. We discussed that in the previous lab. So the number and the order of the columns must be the same in all queries. So you've got over here the number of columns A and B is 2, and then the number of columns in the second query is also 2, and that's why you're satisfying the first rule. The second rule is that the data types must be compatible. You'll see over here the data types of columns A and B is integer and integer, and then the data types of columns C and D is also integer and integer. And that's why this query gives you the results, so a 200 response versus giving you an error, because you do comply with the rules of the union operator. Now, when you're conducting a SQL injection attack from a black box perspective, you don't actually know the number of columns that the query is using, and you don't know the data types of the columns that the query is using. And that's why you need to figure those 2 types out. So that's step number 1 and step number 2 in a union-based SQL injection attack. And we talked about step number 1 in the first lab, so I'm just going to label this step number 1. Determine number of columns. We said there were 2 ways of doing this. One is iteratively adding select null statements. So if you have a query over here, so select a certain number of columns from table 1. Again, you don't know the number of columns because you're approaching it from a black box perspective. So what you could do is add union select null, and if the number of columns in this query is not compatible with the number of columns in this query, then you would get an error. And that's an indication that you didn't use the correct number of columns. And so what you do is add another null value. And if you still get an error, that means you know that it doesn't have just 2 columns. And then you keep doing that iteratively until you get a 200 response code, which is what you're getting over here after you've added 3 null values. And that means that you've reached the correct number of columns, and the number of columns is the number of null values that you added. So because I have 3 null values, I know that the query uses 3 columns. So that's way number 1 of determining the number of columns. Way number 2 is to use the order by clause, which orders by the column that you give it. And so over here, if I say order by 1, it'll order by the first column and you get a 200 response code. If I say order by 2, it'll order by the second column and you get a 200 response code. Now, if I say order by 3, you're ordering by a column that does not exist, and so this is going to throw an error. And when I see an error, that means I know that I've reached a column that does not exist. And so the number of columns that the query is using is whatever value I've reached minus 1. So 3 minus 1, which is 2. And you'll see over here that it has 2 columns. So that was step number 1, determining the number of columns. Step number 2, which is the main focus of the lab today, is to determine the data type of the columns. And the reason that's important is because when I'm exploiting a union-based SQL injection attack, I want to output interesting things like the hashed password of a user and the usernames of the users of the application. And so, since these values are of type text, I would need to output these values in columns that accept data types of type text. And so I need to find the columns that have data type text first in order to be able to output the content. And so the way to do that is similar to the one over here. So I know from step number 1 that my query is using 3 columns. So what I'm going to do is I'm going to iteratively add select statements and put a value of type text in each column and see if it throws an error. So I start off with the first column. If this throws an error over here, that means the column is not type string. But if it doesn't throw an error, then the column is of type string. So over here, if this does not throw an error, that means I know column A is of type string, and so I could use it, or of type text, and so I could use it. Now, if it does throw an error, that means I know it's of a different type, and so I can't use it. And then the next thing that I will try, we do this iteratively, is I'll use the second column and see if this throws an error. And then same goes for the third column. I'll do the same thing and see if this throws an error until I've enumerated which columns allow you to output data type text. All right, now that we've covered the theory, let's start solving the exercise. So the exercise says this lab contains a SQL injection vulnerability in the product category filter. The results from the query are returned in the application's response, so you can use a union attack to retrieve data from other tables. To construct such an attack, you first need to determine the number of columns returned by the query. You can do this using a technique you learned in the previous lab. So that's this one over here, so how to determine the number of columns. The next step is to identify a column that is compatible with string data, which is step number 2 over here that we discussed. The lab will provide a random value that you need to make appear within the query results. To solve the lab, perform a SQL injection union attack that returns an additional row containing the value provided. This technique helps you determine which columns are compatible with string data. Okay, so let's access the lab. And that might take some time. In the meantime, I'm going to remove this and put an analysis tab. Okay, so the vulnerable field is the category, so the product category field. So I'm going to click on gifts over here. And what that does is it filters on the category gifts. And we could see that in the URL over here. So this is about our vulnerable field, and this is where we'll be conducting our union-based SQL injection attack. All right, like we said, step number 1 is to determine the number of columns. And I'm going to use way number 2 to do that. So using the order by clause, so close off the query, order by 1, and then comment out the rest of the query to see if it gives me an error or not. Let's do that. Okay, I don't get an error, which means there's at least one column, which makes sense because you could see over here there has to be at least a column for the name and then a column for the price. Now let's try order by 2. You see over here that it ordered by the second column. Oh, actually, no, it ordered by the second column, which is one over here. So you've got an ID column that exists but is not shown in the page. So that's interesting. You can't use that to output data on the page. Let's try order by 3. And you see over here it ordered by the third column, which is the price column. Let's try order by 4. Okay, and we get an error, which means that it has 3 columns and first column is not shown on the page. Okay, that'll come in handy when we're trying to output data on the page. Now the second step is to determine the data type of the columns. So I know that there's 3 columns, so my query would look something like this. Union, select null, null, and comment out the rest of the query. So let's try with the first one. Although it doesn't really matter if you try or not because it doesn't get outputted on the page, and so it's pretty useless to us. You get an error, and likely because it's an ID field, so it doesn't have data of type string. So let's try. Second column. You see over here that it definitely has data of type string because you've got alphabets over here. So this should work. Let's try it. Okay, and you could see over here that you outputted data. Now let's try the third column. You could keep this over here actually, because it works. Try the third column and see if it outputs an error. And you get an error. So the third value is, sorry, the third column is also not of data type string. Okay, so we only have one column, which is second column of type string. Okay, and so to complete the exercise, we need to make the database retrieve the string over here. And so to do that, we'll be outputting it in the second column. Put that over here. And this should successfully solve the exercise. Here we go. It says, congratulations, you solved the lab. Okay, so we successfully completed the exercise. Now let's script it. And if you're new to this channel and you're wondering why I'm scripting the attack or the exploitation part of the attack, that's because there will come situations in your pen testing career where you will have to automate the attack, and this is just preparation for that. Also, this comes in handy when you're trying to show management the extent of your attack, and instead of having to go through the browser, change a parameter, and so on, all you would have to do is run your program, and then with one click, you show the end result of your attack. So it gives your attack vector much more value, and it's just a much more elegant way of doing it. Okay, so what I have over here is the script that we wrote from Lab 3. And the reason I have it up is because it's the same application. And in this script over here, we did step number 1. And so I didn't want to write it again. We'll just modify this script to do step number 2 as well. Okay, let's do terminal. New terminal. And we're in lab number 4. That's good. And let's run it to see what this does. .py, and we need the URL. So this might have timed out, and it did. So let's open a new one. And while that opens up, I'm gonna open up Burp as well. Close, next, start Burp. Okay. Over here, turn intercept off, and you'll see over here we've got it at localhost 8080. Okay, I'm gonna make this smaller and put it over here. Okay, so let's see what this script does first. You'll see over here in the main method, it takes in one argument, which is the URL of the application, and that's what we're gonna do in a bit. And then it saves it in the variable URL, and then it prints out figuring out the number of columns. There it calls the function exploit SQLi column number, and if it returns a result, then outputs the number of columns is blah blah blah. Otherwise, it outputs the SQLi attack was not successful. So let's look at this function over here. So you've got the path set to filter and then the category parameter, which is the vulnerable parameter. And then it loops through 1 to 50. And then it iteratively tries each value between 1 and 50. And if it gets an internal server error, then it will return the I value -1, which means that you're trying to order by a column that does not exist. And so the number of columns that the application has is I -1. Otherwise, it increases the value of I, and then it runs this whole process again. Now, 50 is something that I arbitrarily picked last time because I can tell that the application has less than 50 columns, but this is definitely an assumption that we're making. Okay, and so it should output the number of columns after that. Let's take the URL of the application, copy that, put it over here, and hit enter. And it tells you the number of columns is 3. And if you go to Burp, in the history tab, you'll see it tried 1 first, it tried 2, it tried 3. It got 200 response codes for all of them, and then it tried 4. It got an internal server error, and that's why it outputted 4 -1, which is 3. All right, so we want to edit this script so that it also tries to figure out the data type of the columns. Okay, to do that, we'll start over here. Let's print figuring out which column contains text, and then create a variable called string column, and the new function called exploit SQLi, string field, and it takes in the URL and the number of columns. And then if evaluates to true, then print the column that contains text is the value of string column. Otherwise, I wanted to print that it didn't find a column that contains text, which is possible sometimes. So we were not able to find column a string data type. Okay. So I'm going to save this and make this a little bit smaller. And this way we could see the entire thing. All right, so what we're doing over here is once it's figured out the number of columns, I want it to figure out the type of data that the column accepts. And it does that by running this function over here, which we will implement right now. So let's create a new function. So exploit SQLi string field, and it takes in the URL and the number of columns. And again, the path is the same path over here, so I'm just going to copy that. And then I'm going to say for I in range between 1 and the number of columns plus 1. So for I in the range 1 and the number of columns, so we know that the number of columns, because we did this manually, we know that the number of columns is 3. So it'll try 1, 2, 3. And then we'll do the string is equal to. So this is the string that we want to output on the page. And it's this one over here. And then I'm going to create a list called payload list and then fill it with null values. And the number of null values is the number of columns that we found from this function. So null times call. And then I'm going to say list I minus 1, because it starts off with index 0, is equal to the string. Okay, and then SQL payload. Union. Select. Join list. And then we add comment field over here. Okay, and I'll explain this in a second. Let's just finish off the function. So it makes a request. So the URL plus the path plus the SQL payload. Verify set false. And the response gets saved in a variable res, so r.text. And then if string dot is in the response, then return I, otherwise return. Okay. All right. So in order to find the column that contains data of type string, what I need to do is I need to run a bunch of union select null statements, right? So in this scenario, what we did is we're doing this. We start off with the first one and we put a certain string. So let's say A in this case. And then we run this and then we loop through it again. If we get an error, we loop through it again. Except in this scenario, we put it in the second column and so on. Then we do it for the third column and so on. And that's what the function is doing. So the path is the path to the vulnerable parameter, and then it's looping through the number of columns, which is what we got from this function over here. It creates a payload list. So it creates a list that contains a bunch of null values that represent the number of columns that are in the SQL function. And then it sets the I value, so the one that we're currently looping with, to the string value, so the string that we need to output in the page. And then it calls the request. Now, if it finds that the string is represented in the page, so if it sees it somewhere over here, then it returns that number. So that's the column number that is able to contain data of type string or of type text. And so it returns it and it'll output it on the page. Otherwise, it will loop through the next column and so on. And if it doesn't find a column, it'll return false. Now, what we're doing over here is string. So that's the string over here, dot strip. So what we're doing is we're stripping it out of the single quote over here because the single quote doesn't actually appear on the page. So if you just compare it on the string value itself, which is this one over here, you won't find it on the page because the single quotes do not get represented on the page. This is just for the backend SQL query, and that's why we're doing that. Okay, let's save it and see if there's any errors. So Python 3, SQLi lab 4.py. And again, I'm gonna see if this timed out, and it didn't. I'm just gonna copy this. Okay, hit enter. And it says, oh, so it's lab number 3. So we get an error, and the error is in line number 24. And that's because payload list. Let's save that again. Okay, it's figuring out the number of columns. And we get one more error, and that's in line number 25. So the error over here is also the list, so payload list. Hopefully this should work and shouldn't give you an error. Okay, this is a good sign. Awesome. So it says we're figuring out the number of columns, and then it figures out it's 3, and then it tries to figure out the column that contains data type text or data type string, and then it says the column that contains text is 2. So we go here. I'm just going to put a space so that it looks a little bit better and save this. And let's look at burp. I'm going to run it one more time. Okay. All right, so you could see over here, it tries to order by 1, and then it orders by 2, it orders by 3, it orders by 4. It finds the internal server error, and that's why it knows that the number of columns is 4 minus 1, which is 3. And then it outputs this over here. Next, it's trying to find the column that contains value type text. So it starts off with the first one, and it gets an internal server error. So it knows that the first column does not accept data type text. It tries the second column over here, and it gets a 200 response. It checks. So what this does over here is checks if the string is in the response. So let's do that. B2F, 6U, A, and it says it found 2 matches. Here we go. So it's in the response. So it knows that the second column accepts data type text or data type string. And that's why it outputs the column that contains text is 2. Okay, so we've successfully completed the exercise. To recap, in this video, we first manually ran a SQL injection union attack in order to determine which columns contain data of type text. We then scripted that exploit so that it automatically does that for us. In the next lab, we'll learn how to actually extract data from the database and output the usernames and passwords of the users of the application.